All right. Good morning, everybody. Hopefully you have a great conference so far. Today we are going to talk about a journey for Expedia Group. So for those of you who don't know who Expedia is, we are a travel online company. We sell hotels, flights, activities, cars, and so on and so forth. And we are migrating, as you can guess, to GraphQL. So during this presentation, I'm going to split it into two main sections. Why? We didn't choose GraphQL because it was sexy. We didn't choose GraphQL because it was fun. We chose GraphQL because it had a value and we had some problems to solve. And then the second part of the talk will be about how we solve that problem. A bit of architecture, a bit of coding, and see what are the benefits we can get from there. And before we start, I want to emphasize something, which is our context of operation. Overall, once that journey will be pretty much done, so everybody will be moving to the GraphQL platform we are building, it's going to be roughly 500 plus developers spread across the world working on GraphQL in the way I'm going to describe later. Right now, we are talking about more than 20 APIs. One's about hotels, one about activities, cars, bookings, plenty of things, right? And we have roughly 50 plus front-end applications. It could be iOS, Android, PWA, and so on and so forth. And the first part of the journey onto understanding why we are migrating is discoverability. This is a real API. This is something we have, something I extracted from one of our servers. When I see something like this in an API, I have no idea what I can do with it. If I'm a consumer of the API, if I'm a front-end engineer, and I look at it and say, all right, it seems heavy, it seems bulky, I don't know what are the types, I don't know if some fields are not necessarily mandatory or will not get back to me every time. So if there is, in that specific example I highlighted, or sorry, to expand a field that is null, and I'm trying to say, okay, but there is a list that is missing, and that list have more data structure, it's really impossible to see that, right? And that's just one endpoint. What are the other endpoints? How do I discover that? How do I know what the API just by itself is capable of? And again, that is one API. I mentioned that just 2 seconds before. We have not one, we have tens of APIs. So if I take that problem, if I take that way to do things, and that discoverability issue, it's not that once, it's so many times. The second part is one too many API. It's very hard for front-end engineers to work when you have so many things to do. And even for product managers. If I want to have a feature to display to my customers, basically you, that shows a new piece of information, sometimes it could be a product information, like, oh, you have a free breakfast, or a new legal information, like the way we show taxes and fees on for different countries. If I want to change that across all the devices, because it's important to have that journey towards cohesion across all devices, it becomes very complex, because obviously you're going to have the web app, or the web apps, using a set of API. You're going to have sometimes the mobile app using another set of APIs, and so on and so forth. So having a lot of APIs makes things very hard to push out and makes the rollout very complicated. And there is no consistency. If I take the room we are here, we have today, and we make teams, and say, here's a simple API every team should design. I'm pretty sure I'm going to have one API style per team, which is fine, which is completely understandable. We are going to have people saying, you know what, we should do that like classic REST. Some people will try to go RESTful, AthOS. Some people will go gRPC, GraphQL, whatever you name it. And that's just for the high-level type of APIs. Then we're going to go with how the API works, how do we project a lot of things. And so if we take a team, or a lot of teams building a different kind of APIs, they all will be different. And that's very complex then for front-end engineers or client-side engineers. Say, okay, I have API for hotel expressing things like this. I have the API for flights expressing the same concept like a price, a date, and we're going to talk about them a bit later, this way. And so they spend so much time working on the plumbing and adapting their code into everything they do, all the API styles, rather than focusing on one important thing, which should be their primary job, working on the customer experience. Because at the end, let's be honest here, the thing that matters is for customers to be at ease with our e-commerce platform, right? If they have confidence into what we present, which means that the price is shown the same way with the right formatting, with the right language, and so on and so forth, across all the applications they have to go through, then hopefully they will book something, which means more revenue for us. So it's not only a technical choice, it's not a choice for product reason, it's really a choice and pragmatic choice to get there for business reasons. So let's look at at the architecture. So we have on the top a few different kinds of clients. So here I have PWA, so basically web clients, iOS, Android, Alexa, chatbots, name it, it doesn't really matter. Then we had a set of services just below, which are communicating most of the time with domains. So those domain services are super complex. They are doing the heavy lifting in the business of Expedia. The set of services we have in the middle are just here to translate, to orchestrate them, to have business rules, and on top of that, we have the clients. So clients are talking to services, and services talking to domain. Everybody is happy, no problem here whatsoever, right? All the layers are clearly defined, they talk to each other, but, and that's where it starts to get funny, we start noticing that PWA, for example, has two dependencies. iOS 3, I put 4 on, or 3 on Android, and so on and so forth. Obviously, here it's a very simplified version. If you have 10 APIs here, 5 there, 20 there, it's really bulky, it's super complex to maintain. And every time, guaranteed, when you have that kind of architecture that looks clean, you're going to have a service, a domain, for example, domain E in the middle, says, you know what, we expose a new feature, a new piece of information, great. And you have Android say, you know what, we need that piece of information. We want to show that to our users because it's going to help them go in places. And so then they talk to teams owning or maintaining some of the services we have in the middle and say, you know what, we don't have time, we can't do it, whatever reasons. Sometimes great reasons, sometimes less great. So what's going to happen is this. Let's start again. You're going to have something clean, and bam, you have something way less clean, where you have your front ends going down directly to the domains, which doesn't seem to be so complicated and that much problem. Again, but you're going to have a direct coupling between your front-end applications, your domains. You're going to have that kind of like, you know what, we are just going to call domain E just that one time for a short period of time, then we're going to migrate, we're going to refactor. Heard that before? It never works this way. Often it's going to stay there, and the short period of time is going to become 6 months, a year, 2 years, 10 years. Classic. I mean, here we are not revolutionizing anything. In terms of coupling, as I mentioned before, if now the team owning domain E wants to change something, like doing a big refactoring, migrating to a V2, V3, or whatever, they have to find out who's using them, so they don't break, they know exactly who their clients are. Not only they have to deal with internal clients, the services, but now they have to deal with Android, iOS, or front-end applications. If we're talking about web apps, it's kind of fine. We can redeploy a web app, changing an endpoint. If you are talking about apps deployed on the App Store, that becomes much of a problem. We still have today, with our Android app, for example, people using the 2017 version, and we're at the end of 2019. So the backward compatibility, the life cycle of those front-end applications is super important. And there is no fundamental reason why we need those couplings. And so we looked at that problem, and we basically say, let's see how we can solve that like one too many API for our front-end application. So we did something, it's going to be at the top left, where you have BFF. BFF is an architectural pattern, I think propagated by Spotify, but I'm not quite sure. Basically, it means backend for frontend. The idea with a BFF is it aggregates all the services that needs to be talked to and just exposes all of them as once. You can have a tiny bit of rules there, like business rules and logic, but your client side, in that case, one of our web app, only deals with one service and one service only. So then if we have to change something on service 2, 3 on the domains, abstracted. Which is super interesting because now I have a 1-1 mapping, it's tailored, which means that I can remove a lot of logic out of my client side, because obviously, and I didn't say that before, when you have so many like services needing to talk to each other, the orchestration goes up in the stack. It goes on the client side. And you have to be sure that all your clients, in that case Android, iOS, and so on, are orchestrating, having the same logic done the same way. Otherwise, you can have bugs, you can have inconsistency, and it's not going to play well. So with a BFF like this, the team maintaining the web app has one service they own. It's decoupled. It hides a lot of complexity from the internal and the business logic. It's great. But the question then becomes, when we are the scale of a lot of teams, I mentioned 500 plus developers, how do we scale that? Not only technically, scaling up, scaling out, that's fine, that's easy. But how do we scale that functionally, organizationally? Right? We have teams working on hotels, we have teams working on flights. And one of the things we don't want to have is to have the hotel team blocking the release of the flights team because of whatever reason. Right? The worst thing from having a monolith is to have a distributed monolith. So we should look at this very carefully, because otherwise we are going to basically clog all our teams and we won't be able to release whatsoever. So first strategy with a BFF is a single BFF, right? So with a single BFF, so which means one layer for everybody. That's great. That application will handle all the service domains communication. All the clients are going to use that one BFF. A classic one single BFF doesn't scale functionally because, again, if I have my service, my flight team, my hotel team, they don't really know each other. Like we're going to need to redeploy the BFF every time. It might cause some issues, and we're going to have some friction between teams. And it creates, again, a monolith, or in that case, a slightly distributed monolith, which basically means you have all the disadvantage and all the coupling of a monolith, and you have all the complexity infrastructure-wise of a distributed system, and with very few benefits. So then let's look at another way. We can create multiple BFFs, one for flights, one for hotels, like big BFFs, but slightly like more manageable. Sure. The problem is, and I mentioned that before, we have our front-end apps dealing with too many APIs. Here we're only reducing them. So that doesn't really work. I don't have that cohesion. I don't have that consistency. Even though at the beginning of all the projects we can say, here are the rules, we know it's going to drift apart easily. So I don't have coherence, and I don't guarantee cohesion. The idea here is to be able to remove a lot of the logic, a lot of the complexity from the client down to the server side. So then we can change that at will. We can experiment, we can do A/B testing, we can do plenty of great stuff, and our front-end apps can evolve, they can change, they can have much more logic. Then let's look at how we do things like from a technical matter. so far, all the diagrams I just showed you are using REST. Don't get me wrong, REST is a great pattern. The problem with REST is in its thesis, Roy Fielding basically didn't mention how to do things. Right? And so let's do a quick exercise here. If you are building a REST API, how do you express a date? So you return some data. How do you express a date? Can somebody try to shout out something? ISO. ISO, okay. Anything else? All right, so we're going to have formatted like this. Year, month, day. Yeah, why not? Our American friends will recognize this one. It works for them. We are more used to that in Europe. No problem whatsoever. And it's been said before, we have the ISO format. Here with just one piece of information, it's not easy. And that's just for one date, assuming there is no variation. But remember, in the case of Expedia, we are a global company. We have Expedia.be, Expedia.com, co-UK, in Japan, wherever. It's super important as a customer that you see the date of your flight and the time of your flight in the format you're used to. Otherwise, if you are used to the day, month, year, and I show you by default a month, day, year, and you're in the first half of the year, it's going to be super fun. Right? Worst case scenario, we can say, yeah, I can just format that client side. Sure, I can do that. It's not very complicated to reformat a date, but I have to be sure that all my clients are effectively doing the same thing. It's a lot of pressure to be sure everything is done the same way when we are talking about so many data. Another example I like is how do you display a price? It's a very simple one. That doesn't feel right. We're in Europe. We don't show the price this way. Bit better, where we put the trigram at the end. Why not? We can just return a tuple with like two values and say, you know what? Client side formatted however you want. Again, that assumes that all the clients are going to format it the right way. And in the world, so many countries have so different rules. The way they treat decimal points, the way they treat 1,000 separators, and so on and so forth, is just fun. So what we did, we had that kind of look, we had that kind of assessment, and say, you know what? Let's build a new API, the one that's going to rule them all, right? And that could be very tricky. Often we have that XKCD, where basically it's like, okay, we have so many standards, we're going to create a new one, and it just doesn't do any effect. So here we were super lucky to have our leadership teams onto that journey, because again, we looked at those problems not only from a technical perspective, but from a product and a business perspective. So it helped them getting there. So that's a quick tip for you. It's like, don't choose a technology, don't choose a change, just because you see the point technically, see if it fits some business problems. And so if, for my product teams, if I can change something in the backend and roll it out instantaneously across all my devices, including iOS, Android, and so on, it's a win from a business point. So that's something to keep in mind. Let's get down to how. The question here is how to build a cohesive API. Cohesive API means we are sure that the same piece of data is going to be displayed in the same way for all the clients. I'm not going necessarily to deep dive into the front-end aspect of it. That could be another like 3 hours talk. But from an API perspective, we have to be sure it looks the same, it feels the same. We have to be sure that if I talk about flights or hotels or cars or whatever, it looks like one API, not 5, not 6, not 10. The important part in that question is not the how. It's not even the cohesive API or the experience. You see that small asterisk? That's where the problem lies and sits. We have to make that cohesive API without coupling teams. Again, having the flight team, the hotel team, not necessarily stepping on each other's toe. We have to care about to share a common terminology. So if I say price here, it should be priced for everybody, or we should share the same language. It's very easy for teams at some point to drift apart in terminology, which means that we are not really sure on the front end if that means the same thing, because we are dealing about complex problems, and sometimes terminology can be a bit tricky. So that's something to be very careful about. We want to be sure that that API answers customers' problem. And customers in that sentence means people using the website, people using the mobile apps. That's you, basically. I want to answer your questions on behalf of Expedia with that API. You don't need to see the whole complexity of the domain, the whole complexity of how we book a flight across with all the airlines and so on. You don't care about that. You want to be sure that you're flying from Brussels down to New York at this time, and then from New York to Seattle, and so on and so forth. That's what you care about as a customer. So this API is made to answer those questions, which means we are building a front-end API. We are not building a UI API. And last point is we have to be sure we can have various clients, again, mobile, web, chatbots, even system like sending you the marketing email you love so much. We have to be able to answer that, so we have that kind of cohesion. And so, a cohesive API for us means an abstraction layer. The abstraction layer is going to be a GraphQL schema. Spoiler alert. So if as a client you see the schema, first off, remember that observability issue we talked about before? You have a schema, so you know what you get, right? Just before I move on, in terms of abstraction layer, if you have that single schema, you can refactor whatever you want underneath. Your client will not see it. So you can change things as long as the schema is the same, for the sake of simplicity, no problem, refactor whatever you want. Your client, your Android apps and so on, will not see it. Again, for us, even though we are on the back end, we have to answer customers' problem. That's something we keep reminding teams, we keep pushing onto teams, and what are the answers or the questions you're trying to answer? It is crucial for that kind of project, in that part of the architecture, to have that in mind all the time. Mentioned a little bit before, the domain complexity should never be reflected. The domain is something that you own, is where the heart and the complexity of your company is into, but your customers very often don't care about this. I'm not saying that you shouldn't have APIs dealing with this, but that's another set of API. It's somewhere else in the architecture. And finally, if we have all that, we should ease the work of our front-end engineers. So again, they can focus on one thing and one thing only, the customer experience on their platform. As you can guess, we chose GraphQL. Who remember WYSIWYG? Show of hands. Not bad, not bad. So WYSIWYG, the acronym of what you see is what you get. We kind of have the same thing with GraphQL. You know what you get. You have a schema, and you get what you want, and that's super powerful because you select the fields you want. If you have something like a complex schema and you just want to have that tiny URL at the beginning of just the name of the hotel, for whatever reason, you don't need to get that gigantic payload that you don't care about. You just select that property here, easy peasy. The new architecture looks like this. Basically, we still have all our domain services, that doesn't change. All our client, that doesn't change. We replace the middle part. The middle part is where GraphQL lies. You're going to have a set of services, GraphQL services, and I'm going to show you how we build them, that answers those questions. How do I search for a flight? How do I book a hotel? How do I do all those kind of things? GraphQL services. And they are all aggregated with one reverse proxy, a GraphQL reverse proxy in that case. The job here is basically to take all the GraphQL schemas you have for hotels, flights, and so on, and simplistically do two things. Concatenate them, so you have one schema that is exposed to our clients, and then routing say, okay, you are doing a hotel search. You know what? I'm going to route that to hotel service or hotel graphical service, and so on and so forth. So in that, and we have no business logic whatsoever in the reverse proxy. With this, we have simplified the number of endpoints front-end applications talk to. 1. We have simplified the discoverability. We have the graphical schema. We know what we get what we want. That's great. And with this, we have the hotel sim, the flight sim, being able to redeploy as many times as they want, several times a day sometimes. We are doing full continuous deployment here. We don't have any friction, and then we manage in the reverse proxy just the update of the schema. Those services are built, are very simple technically, with Spring Boot and GraphQL-Kotlin. We love GraphQL, but if you have ever looked at GraphQL Java, which is great, don't get me wrong again, it's very complex. If you have to use the programmatic API of GraphQL Java, it's super hard, and if I want to scale that across all my teams and across everybody in the company, it's going to be super hard. What we like, and the paradigm we love, is you write some code, and that generates a schema. Very similar to what we had with ORMs, like Spring Data, or Spring Data JPA, Hibernate, and so on and so forth. Like you write some POJOs, some classes, and it creates a SQL schema. In that case, it's going to create a GraphQL schema. We do that with reflection, so you pass on a list of types, a list of queries. So in GraphQL, for those of you who don't know, you have queries, which are write operations, mutations, which are queries, which are read operations, mutation, which are write operations, and you have subscription for streaming back. That's pretty much it. It's opinionated, and we could talk about error management and the fact that everybody is in the HTTP 200, but not today, probably next year. With that being said, it's just it's leveraging GraphQL Java at runtime, so we don't have to reinvent that wheel. But let's move on to some code to show you how we're doing it. Here I've started with a very simple Spring Boot project, start.spring.io, and you just say Kotlin, Spring Boot, and you're done. Nothing else. The only thing I did here is, where it is, so I have my Spring starter here. We are Spring 2.2 already. And I have, on my dependencies, just one new dependency. Let's make it a bit bigger. And we're going to remove this. So here, GraphQL-Kotlin Spring Server, which basically takes care for you of the Spring integration and the code generation. You can use, if you want, the schema generator just by itself. There is no problem. There is no tie to Spring or any other framework. If you want to include that directly, it works very well. Again, it just exposes a GraphQL Java GraphQL schema. So then you can use it however you want. In that case, we decided to go one step further. And because we want to use Spring Boot, we directly created GraphQL Spring Server. And that's it. The other configuration I have is, because we're using reflection and we don't want necessarily to have all the classes being exposed everywhere, we say, you know what, in your GraphQL schema, the only classes you're allowed to expose are from that or those packages. I could have multiple here. So that's an easy way to control exactly which classes would be used for by reflection and to create a GraphQL schema. So the way it works is I'm going here, and in Spring, or if you are using JAX-RS, you used to have a controller. In my case, I'm going to have a conference, and I just want to do a query, just to retrieve conferences. So it's going to be a class conference query. I want that to be a component. Spring component, here nothing fancy. The only thing that is going to change is this. Query. It's a simple interface, there is nothing in it, there is nothing to depend on. It's just a markup interface. The reason why we have this is then with GraphQL schema generator, or GraphQL-Kotlin schema generator, we can ask Spring to say, okay, give me all the queries, all the mutations, all the subscriptions. Very easy. And so now I want to have a function which says basically conference. And I'm going to create a conference with, let's say, a name. So we're going to say name, Devox Belgium, and the year is going to be 2019. I can just go here, create class. No, not in a spot file. We're going to keep it simple. What did I do? Create class here. That's what I want. And you know what? It's Kotlin, so we can do something like this. Val. Oops, sorry. And that's it. Same thing as if you do a REST controller. You expose some POJOs. I could do something very similar here to have as an argument. And so if I want now to start my server, hopefully it should work. So first glance here, by default we dump the graphical schema in the console at startup time. So you can see what it looks like. We have a query type, that's a graphical thing. We have a type conference with two non-nullable types, non-nullable properties, and that is awesome. You know what you get. And then you can say here, you can select a conference, it's going to return back a conference. I can go here. So we expose by default endpoint called playground. If you know Swagger, this application, and you have many in the GraphQL world where it's graphical or playground, is what you wish Swagger was. First thing first, discoverability. I'm going to zoom in slightly. I have all my schema. But there is something missing we're going to get back to very quickly. And if I want to type a query, say, okay, you have this. I don't know what I can do. Let's just autocomplete. Oh, there is a conference. What do I have in the conference? I just want the name. No problem. You know what? Now I want just the year. Or I can do both. No problem. And that's when you start doing that kind of thing, you say, okay, I can explore. I don't need a lot of documentation. Just the API tells me what I can do, and I can mix and match everything. Here, I can even do something like this, and that's really fun, actually. If I want to call an endpoint twice, I can use aliases. So I can do C1 and C2. That's really fun. I can recall the same part of the schema different times. If I had arguments for conferences, I can do that several times. Which means one HTTP call coming from my client down to my server. That could be a huge gain in performances instead of having a lot of round trip and back and forth. Another thing we want to have in, or we can have in GraphQL, where is it? Where is my, here. Interfaces or polymorphic types. In GraphQL you have two. You have union types, which is just a markup. The implementations don't know they belong necessarily to a union type. And you have interfaces that basically exposes some common properties that everybody thinks about. So let's use an interface, in that case a Kotlin interface. And by the way, just for the sake of the demo, I'm going to change the int here with just that question mark. If you're not familiar with Kotlin, that means we are putting that field as nullable. And I'm going to do, actually, not from here. I want to do it from there. Very simple. So we're going to demo that a bit later. And so I have my interface, and I can say I have a property in my interface. It's going to be the name, and we have this. Now I can have a data class, an attendee. The attendee here we'll have, what do you say, tickets. There's going to be a new type I'm going to create. Ticket, no. Ticket. And person. Great. Just going to create, no, not that Spring. What are you creating this? Create an enum because we can have, oops. Where are we? So let's create here. Enum class, ticket, and let's just say combi for the sake of it. And because here I have a person, I need to override and put my string. Let's create a new top level field. Fun. Attendee, or let's say person or people, it's going to be funnier. People, we're going to say we're going to return person. Actually, a list of persons, I prefer that. And list of a first attendee, where we have the name is going to be Jane, and she's having a combi ticket. Let's start with this. We redeploy, and we're going to see something a bit interesting in 2 seconds. And is it redeploying? All right, it's redeployed. Let's look at the schema first. So here, as you can see, remember I put year as nullable. I have nullable types in GraphQL as well. And that's why we chose Kotlin, not only for the syntax, not only for everything that Kotlin brings, the great stuff, but because it's a great match in terms of language with GraphQL. So I know that now, as a client, I need to care about the null type here. Otherwise, I wouldn't have to. And so if I'm doing some code generator client side, it's great because it's much more powerful. So now if we look back at our attendees, so we have, it was people, I believe. And in people, the only thing I can do is name. Why? Simply because here in my schema, it shows a person. A person only has a name. If I want to have, and to talk about the implementation, it's very easy. I say, you know what? Even though that's a list, and here we're describing what the fields we want for every element of the list, we can just say here, when it's an attendee, can you bring me back the ticket as well? If I had, and let's do it here, another speaker, which basically is going to have val talk, here title is going to override the name, as a speaker is a person, surprisingly. And now I want to add a person where the name is me, and the talk, no, sorry, what was the, yeah, it was talk. Speaker, oh yeah, thank you. That's why it didn't work. Awesome. So I said I have a talk, and GraphQL-Kotlin is great. Why not? We can have something like this. We reboot. No, I'm not using Quarkus. Should. I thought that actually updating the demo, but I didn't. Refreshing. So now remember, I have this exact same query, but returning 2 subtypes, 2 implementations. Hey, it doesn't, no problem. Because the second one is a speaker. It's not an attendee. If I want to return and to get the talk, guess what? on speaker, give me the talk. Polymorphic types, and that is just awesome. When you start getting there and having those kind of complexities and things, it's just a pure joy then to use the API, because you know what you get what you want. Let's go back to the presentation. Not sure I mentioned that before, but just for the sake of it, GraphQL-Kotlin is open source. Feel free to use it. Feel free to give us feedback, issues, pull requests. We love that. Now the third part of the talk is going to be to talk about the next phase. Great, we have identified problems. We think we have a great solutions. What are the hoops we have in that journey? For us, and that's just our use case, that's just our feedback, we had two shifts. We had one shift about technology. People were used to like classic Java services, REST APIs, done in very different fashion. So they had to relearn this, which is fine, but there was a mindset shift. And that's the bigger one, that's the biggest one. Where again, we are not necessarily dumping all the domains, not say just exposing a bunch of stuff. We have to think about how we are building that schema. The way we do it is we looked at what our designers wants to display to your customers and say, okay, here you should display the price like this. We are going to answer that question because that's what you want to see. Not more, not less, just that. And then using all the polymorphic types, nullability, and so on and so forth that we know about. And so for people to say, we have to be much more precise, we have to look ahead, we have to talk to others, including designers. That's weird, but they have to get there. Some of the tips I can share with you is we started across all the services, all the GraphQL services developed with GraphQL-Kotlin to have some common types, simple ones, money, dates. For us, if you want to pass in a date as an argument, it's going to be 3 fields, day, month, year as numbers. And because we do schema reviews with teams and not only pull request, we're used to pull request, but we're looking at the schema. And if we see a date pass as another format than the one we think they should use, or the one we are getting for everybody, basically we ask them why. Very often, it ends up in, yes, but you should use the common one. So we're all sharing the same terminology, the same way to do things. There is a technique called schema linking, where basically you can have the hotel service returning a customer ID, and the customer saying, okay, you can get the customer information by ID. And so instead of having a transversal call from hotel service to customer service, we can have the reverse proxy automatically picking that up and basically doing more or less a foreign key. So it's like when you do a join in SQL. In that case, we're expressing the schema in a certain way that, okay, you're returning a customer ID. We change the time in the schema and say, there is a customer people can select, and if they select it, then it's going to automatically call the customer service. So that's very interesting because we decouple completely teams. They don't share business knowledge, they don't share a bunch of stuff, but we can start combining features amongst teams. One of the things I mentioned is you know what you get, and you get what you want. If you get what you want, it means that for me, backend side, I know what you want, and I can start reporting onto it. Here, in that case, you see property at the top. It's the same thing as hotel, but we decided to align on another name. And I know that for that property ID, you know what, 41 clients needed that over the last 5 days, I think, or last day. I have description, so GraphQL-Kotlin, just put an annotation on the type, on a function or anything whatsoever, at GraphQL description, and it's going to appear in the schema. So that's where it's coming from. So it's like when you do OpenAPI or some part of with Swagger, it's directly with the code. And it's interesting to see that the offer badge at the bottom only has 4 clients. And because we can deprecate, there is a technique to deprecate in GraphQL, I can start now thinking like, okay, hang on, are people using this? Who's using that? I can talk to them and say, you should move on to the next field. You should move on to the next way to do things. And not just starting to say, we send an email, we're going to send a scary email in 2 weeks, a very scary email in 1 month, and then just do a scrim test. That's the classic way. Here, I know exactly who's doing what and how. And because I know all that, I can start to have very interesting patterns. People are using pull request. During the pull request, usually we have a build. In this build, I will have unit test, integration test, whatever you want. But it doesn't tell me one thing. If I change the schema, will it break somebody? So what I can do is I can have something like this. That's a pull request I created in one of our services, just for fun. And I did basically this. I can show you actually on the code. I just need to remove this from my screen. I have 2 minutes to show you this. That's a fun one. So let's take a look at conferences. There we are. Just going to go multiple line. Property, graphical ignore. If I do this, I restart. Basically, the year field will not exist anymore. I can do something very similar. Here, in the case of the property, it's this. So actually, let's remove this one for the sake of it. We can redeploy because it's quite fast. Yeah, I know. I just noticed. Thank you. So let's do something like this. And so remember, people, graphical ignore, where it is here. I can just refresh, and I start to see that people doesn't exist. So I just did that in my pull request. All the tests were passing, green build, awesome. But if I had deployed that, and because we looked automatically back at our traffic over the last 5 days, in our case, we say, you shouldn't deploy. And we block the pull request directly and say, you would have broken 2 operations, 2 queries if you wish. And that's super powerful because that gives us confidence into how we deploy, and we can then see who are doing what. The last bit of tips I have for you is automation. Automate as much as you can. Here I talked about pull request. That's an example of some of our pipelines. We have those check every time at different stage in the pipeline. So automate, 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 automate. Testing, schema validation, whatever rules you want to enforce in the schema, it's possible. You can easily do it. So please do those kind of automation tests. And I want to thank you. I am Guillaume Scheibel. I'm a developer at Expedia Group. And if you have questions, I'm here for you. Thank you.